So when we want to take a look, ladies and gentlemen, at your total distance traveled, remember, total distance traveled, we're going to integrate the absolute value velocity function over a certain time period. Remember, distance traveled is a scalar. Remember, when I say a scalar, it's just a number. So displacement, you simply just integrate the velocity over time. Total distance traveled, remember, you're going to integrate the absolute value of the velocity function, which is when we talked about total area a couple days ago. Distance traveled, remember, you're in essence integrating your speed function. Remember, speed is equal to the absolute value of the velocity function. So to find your total distance traveled, you're actually just integrating your speed function. So just like when we had to do total area, when you do not have a calculator, if I ask you about distance traveled, you've got to check to see if there's any intervals where the velocity is negative, and you'll have to split your integral. So you've got to look at the graph or check to see where velocity is negative. So for example, in part A, find your displacement. So to find the displacement, I'm given the velocity function. Remember, displacement is just equal to the integral of the velocity function. So then to find your displacement over this time interval from 0 to 3, I'm just going to integrate from 0 to 3 t squared minus 2t dt. So when I integrate t squared, that's going to give me a t to the third over 3 minus, what's my integral going to be when I integrate 2t? That's going to be just what? T squared. So now remember, I need to evaluate this from my time period 0 to 3. So I plug in 3 for t, so that's going to give me 3 to the third, which is 27 over 3, minus 3 squared, which is 9, minus 0. So what is my displacement going to be? My displacement is going to be equal to what? 0. So there's my displacement. So when you're given the velocity function, and I'm asking to find the total distance traveled, remember your distance traveled is going to be equal to the absolute value of the velocity function. So distance is going to be equal to the absolute value of t squared minus 2t dt. And again, I'm looking at my time period from 0 to 3. So to check to see if there's any place where v of t is less than 0, what you're going to have to do is take your velocity function and set it equal to 0. And do your number line test to check to see if there's any place where velocity is negative. So if I factor t out, that's going to give me a t minus 2 inside my parentheses. So my critical numbers turn out to be 0 and 2. Remember, I'm only going from 0 to 3 anyway. So the question I want to check is, I want to check to see if there's any place where velocity is less than 0. So if I plug in a 1, I know that's going to give me a negative. So from 0 to 2, what I know is that velocity is going to be less than 0. And then if I plug in a 3, that's going to be a positive, or a 2.5. So what I'm going to have to do is I have to reflect that region of the graph from 0 to 2 above the x-axis. So that to calculate my total distance traveled, and I'll do this after lunch, I have to split my integral. So I have to negate from 0 to 2 of t squared minus 2t dt, because that's where my velocity is negative. Then I'm going to have to add it from the 2 to 3 t squared minus 2t dt. So any questions on how you check to see when the velocity is less than 0 when you're trying to do the total distance traveled? All right, and we'll finish this after lunch. The acceleration function. So to find the velocity, we have to integrate the acceleration. So then v of t is going to be equal, again, we're not using this time frame until we actually want to calculate the displacement. So this is the indefinite integral. So after I integrate, what are we going to have to remember to add? We have to remember to add the c, and that's where we use that initial condition to help us solve for c to find the velocity function. So when I integrate sine of t, so what is your integral of sine of t? Negative cosine of t plus c. So then to solve for c, this is where I use that initial condition. When t is equal to 0, the velocity is equal to 1. So 1 is equal to negative cosine of 0 plus c. Well, what is cosine of 0? Cosine of 0 is 1. So I have 1 is equal to negative 1 plus c. So c is equal to 2. So then b of t is going to be equal to negative cosine of t plus 2. So now I'm ready to go ahead and find my displacement. I'm going to integrate my velocity function of negative cosine of t plus 2 dt. What's my integral of negative cosine? Negative sine t. Integral of 2 is going to be a 2t. And again, I'm going to evaluate this from pi over 4 to pi over 2. So I'm going to plug in my upper bound, so negative sine of pi over 2 plus 2 times pi over 2. Subtract it from the lower bound, so I have negative sine of pi over 4 plus 2 times pi over 4. Put a multiplication sign there. So now let's sign up. We know sine of pi over 2 from the unit circle is 1, so I know this is going to be negative 1. Plus 2 times pi over 2 is just going to give me a pi. Minus sine of pi over 4 from the unit circle is going to give me negative square root 2 over 2. 2 times pi over 4 is going to give me a pi over 2. Not a pretty answer. So let's see what I can combine. Well, I have a negative 1, nothing I can combine with a negative 1. I've got the minus negative square root 2 over 2, so far I've got negative 1 plus square root 2 over 2. Pi minus pi over 2 is a positive pi over 2. So without a calculator, that's how I'd have to leave my final answer. So what I usually do, ladies and gentlemen, especially when those bounds do not have a 0, and you have more than one term, you notice what I'm doing is I'm putting parentheses around where I plugged in my upper bound, minus parentheses around where I plugged in the lower bound, because again, you want to be careful with this negative, you don't make a careless subtraction mistake. All right, so any questions on finding the displacement? All right, so any questions on that? So now, total distance traveled. So remember, for total distance traveled, remember, I know it's going to be by integrating the absolute value of the velocity function. So without a calculator, what I have to do is I have to figure out where intervals would my velocity be negative. So what I want to do is I want to set my velocity function equal to 0 and do that test to see where it would be positive or negative. So again, remember, velocity is negative cosine of t plus 2 is equal to 0. So I'm looking at where is cosine of t equal to 2? Can you solve that? No, it's not possible, because remember, what's the range of cosine? The range of cosine is going to go from what? Negative 1 to 1. So this is not possible to solve. So what's happening here? Is there going to be any place where the velocity is negative? No, there is no place where velocity is negative. So again, the v of t is always positive. So therefore, the displacement is equal to your distance traveled. So therefore, your distance traveled is going to be the same answer as we got in Part A, that -1 plus square root 2 over 2 plus pi over 2. All right? So any questions on, so it is possible, so that's what happens when your displacement is equal to the total distance traveled. All right, so any questions on how you can handle these problems? Again, with a calculator, you would just simply have to type in your integral sign and take the absolute value of the velocity function. All right, so any questions on no calculator doing distance traveled or displacement? All right, now let's take out your calculators. Let's do some calculator stuff. So there are going to be times, ladies and gentlemen, where you may actually have to solve for one of your bounds when you're dealing with a definite integral. So let's take a look at example 4. So the velocity of a mouse running along a baseboard of a room is modeled by the function. So again, notice they're giving you the velocity function. And the time period we're looking at is from 0 to 6. Estimate the time at which the mouse is 2 meters from its starting position. Keyword position. So first of all, when I want to solve for time, that's an indicator I'm going to have to solve for one of my bounds. Because I want to know the distance from its starting position. So what function do I have to know? I have to know the position. So I want to know what the position function, first of all, is going to be. And then I want to know when is my S of t going to be equal to 2. So at what time is the position 2? Is there another time that I consider to solve for as well? Because we think about position. Position, I could be in the positive direction, or I could be in what? Negative. So I also need to know when is S of t going to be equal to -2. So any questions on what I'm trying to solve for at this point? So first of all, let's talk about, they're giving me the velocity function. So I know that I'm going to have to do what with my velocity function to get me to my position function? I'm going to have to do what? I'm going to have to integrate. And again, I do not know that upper bound, so I'm going to call that an uppercase T. And I'm going to have to integrate my v of t dt. So then from 0 to t, they're giving me my velocity function as 3 over t squared plus 1 minus 0.5t dt. So even though it's a calculator question, you do have to do some work by hand first. You're going to have to do the integration part by hand. All right, the calculator will evaluate a function for you, but it's not going to tell you what the position function is given velocity. So you have to find that by hand. So first of all, how am I going to integrate this 3 over t squared plus 1? It's going to be 3 times your inverse tangent, and again, I'm just going to plug in the uppercase T, minus. Now I have to integrate 1/2 t squared, and what's that, 1/2 t? That's going to integrate to minus 1 over what? 4 t squared. So any questions on how I found the position function? Now what am I going to have to do with the position function? I'm going to set my position function equal to what? 2 and -2. So 3 times your inverse tangent of t minus 1/4 t squared is going to be equal to 2. And then 3 times your inverse tangent of t minus 1/4 t squared is equal to -2. This is the part where you can use your calculator for. All right, so again, what mode? Remind me again, what mode does my calculator need to be in? Radian. So I'm just going to go under my y equals, and I'll type in 3 times my inverse tangent, second tan of t, or x, minus 0.25 x squared. And under y2, I'm going to type in a 2. So how many answers am I going to have? 2. So I'll go to second trace, intersect. So 1 time's going to be at 0.903 seconds. And then when I do my second trace again, I end up 2.510 seconds. So any questions on that part? You guys go ahead and answer the second part for me. I'm sorry? But remember, we're only looking from 0 to 6. Yeah, so we got those 3. All right, so any questions, guys? And again, this is where when I'm doing calculator problems like this, I always adjust my viewing window given that particular interval. Again, I'm only looking from 0 to 6. So I always set that x min and x max to those t values, so that way I know that I won't accidentally put a wrong value in there that's not in the restricted domain. Okay? So any questions on how, given velocity, you can solve? Because sometimes that's how you'd have to solve for a bound. All right, so any questions on example 4? So again, these questions we answered in example 5 we saw back in chapter 4. So notice they're giving you the velocity versus time curve. Again, always pay attention to the graph they're giving you. They're giving you the velocity curve. And again, you're looking from 1 to 5. What can you say about the sign of acceleration over the time interval? How do you know? It's sloped downward, or we could say that v of t is doing what? It is decreasing. So it is negative. So a of t is less than 0 because v of t is decreasing. And again, remember that that means is your slopes are negative. So your acceleration is negative. When is the particle speeding up and slowing down? So thinking back to what we did back in chapter 4, when are we speeding up? I mean, in terms of the justification, what has to happen to be speeding up? A of t and v of t have to be what? Same sign. So where am I speeding up then? 2 to 5. Because again, if you look from 2 to 5, you know velocity is negative. Acceleration, we already stated, was negative. So again, a of t is less than 0. V of t is less than 0. So I'm speeding up from 2 to 5. To be slowing down, remember, to be slowing down, what has to happen with acceleration and velocity? They have to have what? Opposite signs. So then where am I slowing down? I'm slowing down from where? 1 to 2. And again, remember, v of t is greater than 0. A of t is less than 0. Okay. So any questions, again, going back to what we did back in chapter 4, given the velocity graph, how you know whether or not you're speeding up or slowing down? So really the only new part of the question we're looking at is part C. What can you say about the location of the particle at time t is equal to 5 relative to the position at t is equal to 1? So we're considering the position of the function, correct? So remember, the position of the function we know is the integral of the velocity function, correct? And remember how we started the definite integral. what in essence, when we're looking at a graph, what is your integral? It is the area under the curve. So, do you agree with me that we know from 1 to 2, the area under the curve is positive, correct? What's happening with the area under the curve from 2 to 5? Negative. Is there more of an area that's negative than positive? Yes, you agree with me that this whole region, there's a lot more region where this area is negative than positive, correct? So in terms of position, we talk about negative. Where are we? We are to the what? Left. So compared to S of 1, S of 5 is to the left. And again, there's more area below the x-axis from 2 to 5. Or when your V of t is less than 0. So don't forget, any times when you're looking at the graph, again, what you're looking at when we're looking at the integral, you're looking at that area under the curve. Okay? So any questions on example 5? So last example, and again, this is a calculator question. So again, they're giving you velocity. So generate the velocity versus time curve and use it to make a conjecture about the sign of the displacement over the time interval. Now remember, we're only looking from 0 to 1. So let's take a look at, and again, remind me again, how do you find displacement? Displacement is equal to what? When you're given velocity, it's the integral of v of t dt, correct? So when I'm looking at the graph, what am I going to be looking at? I'm going to be looking at the area. All right, so again, remember, I'll be looking at the area. So again, I'll use my calculator to graph this. So I'm going to go x natural log x plus 0.1. And then again, I'm only going from 0 to 1, so I'm going to make sure I adjust that on my calculator screen. And since I'm looking at a small window, I'm going to shrink down my y min and y max too. Let's see what this looks like. So again, I used a viewing window going from -1 to 1 on the y-axis and then 0 to 1 on the x-axis. So tell me about your displacement. What do you think is happening with the displacement? Positive or negative? Negative. How do you know? More area that's falling what? Below the x-axis. Okay, so displacement is negative. And again, there's more area below the x-axis. And again, this is where your v of t is less than 0. And you can find this x-intercept to find out exactly when the velocity turns positive by finding your x-intercept, going under second calc and find that 0. So the x-intercept rate here is 0.9. So we know that v of t is less than 0 from 0 to 0.9. So use your calculator to find the displacement. So to actually calculate this displacement, remember, to find your displacement, all you're going to do is you're going to integrate, again, your time periods from 0 to 1 of your velocity. Is it the absolute value of velocity, or am I integrating just velocity? Just velocity. If I want the total area or total distance, I would take the absolute value of the velocity. So remember, to integrate, what I'm going to do is simply go to my alpha window, option 4, go from 0 to 1. Again, the function's already loaded under y1, so I'll go to alpha trace y1. And notice I do get a negative 0.164. When you are dealing with calculator questions in calculus, guys, answers alone are never sufficient. Notice I am not just writing down negative 0.164. You will show me that you actually integrated and what function you integrated. If you decided to actually write out that t ln of t plus 0.1 in the interval, that's fine. But v of t is defined up here. So it is okay just to show me that you integrated the v of t. All right? Not that I know we're all perfect people and we never make careless mistakes. But I know it is possible you accidentally may hit a wrong negative sign or a wrong plus sign or hit a wrong number on the calculator. Well, with just an answer, I have no choice but to give you absolutely no credit. Versus if I see your setup, I say, oh, well, you knew what you were doing. Obviously, if you got the wrong answer, it was just a careless typo. So I can give you a lot of points, and that's the same thing on the AP exam. A question like this may be worth 3 points. The answer itself may only be worth 1 point. So even if you get the wrong answer, it's still possible to get 2 out of the 3 points if you show the correct setup. All right, so you always want to make sure you're showing me where these answers are coming from, even if they're calculator questions. All right, it will help you in case, I know we're all perfect people, but sometimes we make careless mistakes. You guys go ahead and do part C for me. Did we all come up with 0.174?
Yeah.
Okay. So any questions on doing these problems with or without a calculator? Because they could be either one. They could be calculator or no calculator. All right. Any questions?